Introduction. For introduction, first, sustainably managing fisheries resources is critical for ensuring the long-term health and productivity of marine ecosystem. Around the world, many fish stocks have been depleted through overfishing, destructive practice, and inadequate governance. The study aims to evaluate policy options for implementing sustainable fisheries management in East Coast Malaysia. Focus commercial fisheries include demersal trawling, pelagic reef netting, and invertebrate potting. This study will apply bioeconomic model that integrate biological and economic factors to evaluate management options for key commercial fisheries in East Coast Malaysia.
Based on the previous study reaches 2019, February 1st, the management of fisheries in order to enhance their sustainability has primarily focused on the environmental aspect, such as conservation of the seafood stocks and technological issues. Nonetheless, fishing behavior is largely driven by economic incentive, and in recent decades, the social and economic aspects have been considered equally essential. Furthermore, social economic indicators of fisheries are important measures used to predict, explain, monitor, and evaluate the consequences and impact of the fishing management decisions, such as input control, which is number of size of vessel, gear and mesh size, and temporal closure, and output control, which is size limits of the species and catch quotas. Moreover, socio-economic indicators of fisheries play a crucial role in forecasting, elucidating, tracking, and assessing the effect and ramification of fishing management choices. Examples of this decision include temporal closure, vessel size and number, gear and mesh size, and size limits of species, as well as catch quotas. The benefits that fishery resources can provide really depend largely on how well they are reviewed. Based on article White Shrimp Production System in Central Vietnam, Status and Sustainability Issues by Van Nitrogen 2021, serious sustainability problems with white shrimp farming technique currently prevent more development, increase pollution, and put smallholder in the highly dependent position on intermediaries, while white shrimp farmers have taken steps to adapt to and address these difficulties. Their efforts have been largely ineffective and short-lived.
So the next one is data sources. So this research utilized secondary data obtained from studies conducted by various researchers, focusing on the same issues. The option value is determined in the non-used value, and the data analysis is carried out using Excel software. The Department of Fisheries, DOF Malaysia, is the source of the secondary data, spanning from 1992 to 2022. The data provided by DOF includes time series information on catch, effort, fishing gears, and vessel, which will be analyzed in the context of bioeconomic modeling. Okay, the next one is descriptive method. This method is one of the qualitative methods used in the study to evaluate the population. This method is used to obtain the mean, standard deviation, and also variation. Mean is the average of value for a group calculated by summing all of the available data with the number of data. This study also used standard deviation to measure the amount of variation and show the diversity of samples that can be used to obtain data and population, while the variance calculates all the available data to distinguish the range that depends on two measurements, which is the lowest and also the highest.
Next is regression. Regression is a statistical method using in financial investing and other disciplines that attempt to determine the strength and character of the relationship between one dependent variable and independent variable. There are various types of regression analysis. We using a simple linear regression and multiple linear regression. This is a model for simple linear regression. Y equal to A plus B x plus arithmetic, where is dependent, Y is dependent variable, and X is independent. A is intercept, B is slope, and error is residual or error. This is for model for multiple linear regression. Y equal to A plus B x1 plus C x2 plus D x3 and error term, which is Y is dependent variable, x1, x2, x3 is independent, A is intercept, B, C, D is slope, and error term is residual error. Next is Fisheries model. The Fisheries development model provides a framework for assessing fisheries system holistically and a method through which organizers can truly compare the system, identify possibility, development and test a strategy and scale effective intervention. First is fisheries science. In order to find measures to conserve fisheries resources so that sustainability exploitation is possible, fisheries management make use of the fisheries science in an offer to present a comprehensive picture of fisheries is multidisciplinary science that draw on the field of ecology, population dynamic, economy and management as well of oceanographic, marine biology and marine conservation. Stock requirement model. The link between stock and requirement is crucial to the management of natural disasters, particularly fishes and shellfish stock. Next is a study area. The study area of this study cover the 4 landing stage in Peninsular Malaysia, and all 4 are on the east coast of Peninsular Malaysia, which is Kelantan, Terengganu, Pahang and Meseng, Johor.
Graph 1 shows data on the number of tiger shrimp cases from 1992 to 2022. The highest number of tiger prawn cases was in 2006 at 389 cases per unit, while the lowest number of cases was 33 cases per unit in 2021. In 2019, the number of arrests per unit was 140, then this number decreased dramatically in 2020 by 44 cases per unit and then decreased by 33 cases per unit. However, in 2022, this number will then increase with a small amount of 44 cases per unit.
For the maximum carrying capacity MCC, the number of vessels were 2001.12. Under the conditional of maximum economic yield (MEY), it was found that the effort were 2005.42 trawlers and negative 1656.12 metric tons of tiger prawns. The profit for the MSY is negative 647187048.6, and for the MEY, the profit is 34183510457.41.
Graph 2 shows data on the number of cases of white shrimp from 1992 to 2022. The highest amount of catch of white shrimp was in 2003, which was 656 cases per unit, while the lowest catch was 161 cases per unit in 2022. In 2019, the total catch per unit was as much as 350, and the total this has decreased sharply in 2020 by 285 cases per unit and then decreased by 247 cases per unit in 2021. However, in 2022, This number decreased by 161 cases per unit.
Situation for white shrimp in East Coast, it was found that the effort and catch under the condition of maximum sustainable yield MSY both are 935.69 versus 441.96 metric tons. For the maximum carrying capacity MCC, the number of vessels were 1,871.37. Under the condition of maximum economic yield MEY, it was found that the effort were 1,871.37 trawler and negative 2,716.7 metric tons of white shrimp. The profit for the MSY is negative 603273097.2, and for the MEY, the profit is negative 51870.
In conclusion, bioeconomic modeling is useful quantitative tool to evaluate fisheries, management strategies, and assess sustainability trade-off. Potential management strategies include catch limit, gear restriction, and fishing effort reduction. Effective implementation requires an ecosystem-based approach through cooperation between different groups. Ongoing monitoring through stock assessment and bioeconomic forecasting is essential to adapt policies to changing conditions.